Hi everybody, it's Mr. Steger. For our next unit, we're going to be covering energy, and we've got a few short presentations for you that I want to share with you, talk to you a little bit about. The first part is going to be about identifying energy and what it is. The definition of energy is real simple. It is energy has the ability to cause change, and energy has the ability to do work. We'll talk a little bit more about what that means in a second. We have potential and kinetic energy, which will be the next slide, and then we have several types of energy. And it's important to keep in mind when you look at this and you hear what I'm saying, that all of these forms of energy aren't created or made. They're just converted from another form of energy. So energy isn't created or destroyed, it's just changed. So let's take a look at what we've got. There's two types or two groups of energy, kinetic or potential. Kinetic energy is due to the motion of something or the motion of molecules. If you remember that kinetic is motion, you'll be fine. That kinetic energy depends on a couple variables: the speed of something and the mass of something. Potential energy is the result of an object moving, or the temperature of something, or the mass of something. So if we look at this roller coaster ride, we'll see that the potential and kinetic energy graphs are changing as the roller coaster moves. So as the roller coaster reaches the peak of the first hill of the roller coaster, or the cars do, it's got the most potential energy. Think of it as a rubber band being stretched to its breaking point. As it's moving down, it's losing potential energy and gaining kinetic energy. As it moves back up, it's losing its motion, the kinetic energy, but it's gaining potential, and so on. So potential energy is real high here, kinetic energy is low. On the bottom of that first hill, potential energy is low, kinetic energy is high, it's moving as fast as it will, and then that process is repeated throughout the rest of the ride. There are several forms of energy. I'm going to go through the next few slides and explain to you a little bit about what those are. There's mechanical energy. That's movement. Objects are moving, or has the potential to move. And this water wheel is a really good example of that. Water moves through the sluice, falls into the wheel turns, that turning wheel spins an axle, and then that axle transfers the energy to whatever work is being needed. Chemical energy is the energy stored in between the bonds of the atoms or molecules that make up things. When those bonds are broken, energy is released and can do work. A simple example that you might be familiar with is, my cat's here, is a burning matchstick. Wood burns. The wood itself has the potential to do work, to heat things. When that heat is released, those chemical bonds are released, work can be done. The food you eat is chemical energy. Your body releases or breaks those bonds down, and then your muscles use that sugar that's stored in the fruit to do work. Electrical energy is the movement of electrons. Lightning, batteries, sparks made from static are all forms of electrical energy. And then there's thermal energy. Thermal energy is the movement of matter or atoms. All atoms have kinetic energy. They're all moving at a constant or at a variable rate. As those molecules or atoms move, if they move more quickly, they become a gas. If they slow down, they condense into a liquid. And if those molecules have more heat removed from them, they become a solid. Sound energy depends on matter. There are vibrations that pass through either a gas, liquid, or solid. Sound energy can travel through all of those substances, but it cannot travel through empty space. So if you're watching Star Wars, some space movie, and you see a rocket go by or a spaceship go by and you hear those engines thrust, that wouldn't happen in real life. Sound energy depends on particles of matter to pass through. Electromagnetic energy is what we would commonly call light, the electromagnetic spectrum. We see light, which is part of the electromagnetic spectrum, but that also goes beyond what we see into radio waves, microwaves that you warm your food up with, X-rays, infrared. You can see on the middle portion of the slide on the right, the sun gives off electromagnetic energy, lots of different types. And in this case, this silhouette image of a dog, that's done in infrared, which is heat given off by an object. Then we have nuclear energy, which is the release of energy from radioactive material. When that bond is released, energy is given off. Nuclear power plants, our sun and other stars create nuclear energy. Part of that nuclear energy is light, and our plants on Earth depend on that light for their energy. Energy transforms, meaning it goes from one form to another. In using this flashlight, there's a couple batteries. The batteries have chemicals inside. Those chemicals, the way that they're arranged, produce electricity. That electricity travels through the wires to the bulb, and then in the bulb of the flashlight, that energy is converted into light energy and a little bit of heat. So we're going from chemical energy to electrical to light and a little bit of heat. This happens in all forms of energy. Mrs. Arts and I are going to have you do a little activity in this diagram. We have some Usborne Science Encyclopedias that will have you open up to this page. We'll talk more about that in class. Now, moving towards the end of our little conversation here, I wanted to bring up this gentleman, Hero of Alexandria, invented a kind of a unique device called the Hero engine. Essentially what it does is this sphere was sealed, filled with a little water and sealed. As it was heated, as energy was added to it, that water, that liquid began to boil. It went from a solid from a liquid to a gas. As it became a gas, it expanded and pushed out. And that expanding gas is controlled through these small nozzles. When those small nozzles released the expanding gas, it provided a mechanical force which turned the device. We're going to be looking at something like that in our activity. Now, to talk about our activity, it's pretty simple. We're not using heat. But we are using the principle of water moving through an object. We're going to be using soda cans, punching some holes in them. How you arrange those holes will either cause your can to spin hanging from a fishing line or a string very quickly, in which case you'll be going for a speed record, how many revolutions you can achieve in a set amount of time, or how long you can make it go. And we'll be going through these things in class. So that's what I've got for you. I hope you enjoyed it. We'll talk to you later.